comma somewhere else, sure. But yeah, start fresh too. Okay. So two things for each one. First off, I want you to find me what the reference angle is, theta prime, and then I want you to find me a positive and negative coterminal angle with each one. Agree with negative 150 degrees being there. Okay, that gives me a reference angle of 30 degrees. Because it always comes off the horizontal. Reference angles always come off the horizontal. Okay. All right. Coterminal angles. A positive coterminal angle to go along with that is 210 degrees, 570 degrees, 930 degrees. Right? Yep. Okay. Negative coterminal angles to go along with that one would be negative 510 degrees. Does that sound right? Yeah. 450, yep, 510. Negative 870 and negative 1230. Yes? Love it. Okay. Yes? It's a quadrant 1 angle. Quadrant 1 angles are their own reference angle. So theta prime is 70 degrees there. Okay. Positive coterminal angles to go along with that. That would be 430 degrees, 790 degrees, 1150 degrees. Negative ones would be negative 290, negative 450, negative 810. Yes? Okay. 2 pi over 3 is up here, which means this is my reference angle. So my reference angle, theta prime, is going to be pi over 3. Yes? Huh? Positive coterminal angles that go along with 2 pi over 3 would be 8 pi over 3, 14 pi over 3, 20 pi over 3. Negative coterminal angles to go along with 2 pi over 3 would be negative 4 pi over 3, negative 10 pi over 3, negative 16 pi over 3. Yes? 7 pi over 4. Is there. Reference angle would be there. So my theta prime is pi over 4. Positive coterminal angles would be 15 pi over 4, 23 pi over 4, 31 pi over 4. Negative coterminal angles would be negative pi over 4, negative 9 pi over 4, and negative 17 pi over 4. Yes, ma'am? Because we want it to be an acute angle, which means that it has to be between 0 and, in this case, pi over 2. Because it's in negative pi over 4 is not between 0 and pi over 2. Okay? That's why. Okay? Yes, ma'am? Because that's what would happen if I would start here at 0 and go backwards. Yep, between 0 and pi over 2. For the reference angle. And not what? Because the reference angle always comes off the horizontal, not the vertical. Yep. Good? Yes, ma'am. Yep. Coterminals. Add 2 pi and subtract 2 pi. But 2 pi comes in many different forms. So, for instance, in C, 2 pi for me was 6 pi over 3. Okay? And for me in D, 2 pi was 8 pi over 4. Okay? That comes in many different forms. Huh? All right, awesome. So, I want to, if theta is in standard position, what does standard position from yesterday mean? There's 2 conditions for being in standard position. Nope. Vertex is at the origin is one condition. So my vertex is at the origin. And my initial side is along the positive y-axis. So that's my 2 conditions for it being in standard form. Okay? With a terminal side of theta through that particular point. And then I want to find the sine, the cosine, and the tangent of actual theta and actual theta. Okay? Alright? So, again, I start all of these problems with a picture. Where is the point negative 5, 12? Quadrant 2. So left 5 up 12 would put me up there, correct? Okay, because this would be the point negative 5, 12. Yes? Okay. Now, I'm going to add to that another picture. And my other picture is going to be a quadrant 2 right triangle. What sides can I fill in on said triangle to make that angle, to make this angle here, my reference angle, be right here? What sides can I fill in? Yes, sir. Which one is which? So the horizontal one is 5. That's my x value. Okay. So this one could be 5. My vertical could be then 12. Love it. Okay. Do we all agree with that? Yes, ma'am. It's just 5 because it's a triangle. Okay. But yes, in my brain, I'm really thinking that that's negative. Okay. With me? Okay. Do Do I know anything else about said triangle? Do I know anything else? We know it's a 90-degree because it's a right triangle. Do we know anything else? What can I figure? How do I figure the hypotenuse? So I use the Pythagorean theorem. Can we do that one in our head? There is a 5, 12, 13 triangle. It's called the Pythagorean triple. So what does that mean? My hypotenuse is 13. Okay? Now, if we didn't know that, then we'd have to go on and we'd have to do 5 squared plus 12 squared equals c squared. 25 plus 144 is c squared. 169 is c squared. 13 is c. I normally go plus or minus there, but because I'm on a triangle, I'm just going plus. With me? Okay, so that's good. Love it so far. Now, what else can we figure out? How can we figure out theta prime? And use the one that we're given? Okay. So if I go that the tangent of theta prime is equal to what? 12 over 5, right? Okay. So that would be 12 over 5. And then that tells me that theta prime is the inverse tangent of 12 over 5. Right? Done. So that tells me, no, calculator, inverse tangent of 12 divided by 5 times, now mine's in radians, so I got to do times that, then divided by that, and I get here that theta prime is approximately 67.3801 degrees. Yes? Confirmed by a couple other people, hopefully? Yes? Yes? Okay. Now what? Okay. And do what?
No, you can subtract here. Unless your angle is from the top.
If I subtract it from
but that's
90?
using 90 plus 67.180. Or just do 9. Or you can just do 180.
I know. Talk to me. Bring some levity into this debate between if we go from 90 or 180. Ha! Because I'm in quadrant number 2, theta, my actual angle, is going to be 180 degrees minus my theta prime. Right? Okay? So that's going to be 180 minus that gets me 112.62 degrees. Right? So that's what my actual theta is. Okay? What now is the sine of theta? Don't need it. We've already done all the work for it. Yeah, right? Love 12 over 13. What is the cosine of theta? What do you got? Is that what you got? Do we agree with 5 over 13 for the cosine of theta? Show of hands, yes? Be proud of your wrong answer. Why is it wrong? No. Why is it wrong? Why is it wrong? I get -5 over 13. Why? Okay, I like that, but there's an easier explanation for it that we've already given. Because my point's in quadrant number 2. What's cosine in quadrant number 2? Negative. Okay? Or, Brennan, if we go back to yours, if we thought of this as -5, okay, right? Because we're in quadrant number 2, then we'd have -5 over 13. Yep. Okay? Tangent. Tangent of theta. -12 over 5. Okay? So the triangle works, but then we have to go back to our sine is positive in quadrants 1 and 2. Cosine is positive in quadrants 1 and 4. Tangent is positive in quadrants 1 and 3. Okay? What I would like you to do now, on your own, individually, and then when you're done, compare your answers with your neighbor. Okay? I would like you to do this one. Right now. Same thing. But different quadrant. Yes? So we're in quadrant 3. Theta prime is here. Yes? So I would draw my triangle like that. That's theta prime. Depends on if you want to be like I draw it so that it represents where I'm at. You know what I mean? It doesn't matter how you draw your triangle, but I draw it so that it represents where I'm at.
So if you do it a different way, how do you know where to put theta prime?
Exactly.
I'm asking.
Yeah, exactly. That's what I'm saying. How do you know?
So you should draw it.
Okay, you know what I mean? So, in this particular one, this would be 3, and this would be 4, and then I'd use the Pythagorean theorem, and I'd come up with 5 there, right? So as long as theta prime is between the side length of 3 and the hypotenuse, I'm okay. You know what I mean? Opposite the 4. Okay? But again, I can see that nice and pretty if I draw my triangle kind of in the standard position with theta prime. You know what I mean? So, I mean, it's one of those little hints that I picked up on a couple of years ago. And I'm like, this really makes a lot of sense. Okay? But it doesn't mean that that's the only way. Okay? All right? So, then we would say here that the tangent of theta prime is equal to 4 over 3 which means then that theta prime would be the inverse tangent of 4/3, which means that theta prime would be inverse tangent of 4/3 times 180 divided by pi gets me 53.1301 degrees. But because I am in quadrant number 3, my actual theta is 180 degrees plus my reference angle. So that's going to be 233.13 degrees. The sine of theta would be 4/5, right? But because, listen up, but because I'm in quadrant 3, it's negative. The cosine of theta should be 3/5, but because I'm in quadrant 3, negative. The tangent of theta is going to be 4/3, but because I'm in quadrant 3, positive. I saw her hand first.
Okay, so I guess, I don't know, I'm a little confused because, like, using sine theta, but we're using theta prime.
We have to use theta prime to find theta.
What is the sine theta prime?
No, because now I'm using sine of theta. Okay? Sine of theta prime would be 4/5. Because it's theta prime is a quadrant 1 angle. Sine is positive. What works?
Like how you can
Hold on. So again, I go back to sine is positive in quadrants 1 and 2, negative in 3 and 4. Okay? Theta, actual theta, is this whole angle right here. So actual theta is a quadrant 3 angle, so sine has to be negative. But we use theta prime to find it. Okay? Sine is SOHCAHTOA, and TOA. Okay? So I go back to my triangle, right? So sine is 4/5. Because here is my right angle. Opposite over hypotenuse. Because we're in quadrant 3. Tangent is positive in quadrants 1 and 3, negative in 2 and 4. Because if you think about it, what's tangent? Tangent is sine divided by cosine, right? Chels? Right? Sine divided by cosine, right? So a negative divided by a negative is a positive. Okay? Love it. So, now, in general, if theta goes through the point x comma 1, okay, then r is the square root of x squared plus y squared, right? Because r then, this is the hypotenuse of my triangle. Why do we call it r? Radius of my unit circle, radius of my circle. Okay? Alright? That's why we call it r. Okay? So we got that. So we haven't done anything new. Just rewrote it in a little different way. Okay? So the sine of theta, then, is going to be what? Look back on your last two examples. What is the sine of theta going to be? In terms of x, y, and r, what would sine be? Y over r, right? Right?
Why are we putting it over R?
Look at your last two examples.
We always put it over R.
Because sine has got to be less than 1, right? Yeah? Right? So y over r here. Which means cosecant is what? Cosecant. R over y. Oops, I made my y's different. Cosine, straight underneath you. Cosine, what would cosine be? X over r. Which makes secant r over x. Wait for it. Tangent. What? Y over x. Cotangent. X over y. Think back. Unit circle. What's sine on the unit circle? Y, right? Okay? But what's different about the unit circle and other points like the two examples that we just did? Okay, but if I go back here, what was the radius of this circle? 5. What's the radius of the unit circle? 1. So really, the unit circle sine is y over 1, correct? Okay. Well, now the only thing that we're doing here is we're just taking any point and we're reducing it down to on the unit circle by dividing it by r. Okay. If we divide it by r, then we've reduced it down to now it's on the unit circle. Okay? Now, my reference angle is equal to the inverse tangent of y over x, but there's one caveat that goes along with that. And that caveat is we need to drop any negative signs. Okay? Which then makes it become, if we drop the negative signs, now it becomes exactly like what we just were doing on those last two examples. Okay? With that being said, with you having this written down, I would like you to now try this one. Find me the cosine, the tangent, and theta if the sine of theta is 3/5 and secant of theta is positive. It's a little different twist on the exact same problem. So, first off, I got to figure out where this angle is, right? Okay? So this tells me that I am in which quadrants? 1 or 2, right? This tells me which quadrant am I in? Which 2 quadrants is secant positive in? So which quadrant am I in? I'm in quadrant 1. Okay? So theta is in quadrant number 1, which means that theta prime is also my theta. Which means, which sides do I have? What's the hypotenuse? 5. Vertical or horizontal? Vertical is 3. Which means then that this side is 4, if I do Pythagorean theorem. Yes? Okay. So, we could do theta prime here is the inverse tangent of 3/4. Or you could do theta prime is the inverse sine of 3/5. Actually, we wouldn't even need theta prime. We could just say theta, because we're in quadrant number 1. Either or should get you the exact same angle. Inverse sine of 3/5 divided by pi. I get 36 here. 0.8699 degrees. Yes? Yes?
How come when you keep plugging in, it keeps on dividing by pi?
Because mine's in radians.
Oh, okay.
Okay? So my theta is 36.87 degrees. My cosine of theta is 4/5. Needs to be positive because I'm in quadrant number 1. My tangent of theta is 3/4. Also needs to be positive because I'm in quadrant number 1. Questions, comments, concerns, clarifications? Good? Nailed it. Nothing but that. Okay? Right, up here on the front board, I put down the 6 homework assignments that we're going to be collecting on Tuesday. You listen up. Listen up. This is not an excuse to pack up or start side conversations. This isn't very important for some people. You do not have number 6 yet. And you'll get number 6 tomorrow. Okay? Also on the front board, I've put down the 2 formative assessments that we have this unit. So far, you don't have number 2 yet. That's the formative you're going to take tomorrow. Okay? What? What do you think?
I don't know. Yeah, because like if you don't do it, it's not success or something.
Right?
I think it's
But if you do it, what happens?
You're better score.
You're going to do better on the test, which is going to boost your grade. Plus, if you don't have 100% on your homework, it's going to boost your grade.
So like the homework itself doesn't do it. Like,
What do you mean? So your homework itself does stuff to your grade, yes.
But like it's not more that's
If you turn in homework for me, I grade it like I would normally grade it. It's worth points. Above an 85, below an 85.
I don't have voices.
If you turn the homework in, I will grade it like you need to have it done. So it will help your grade if it's done. It will also hurt your grade if you only do half of it. Or then it just doesn't hurt or doesn't help. You know what I mean? If you do it, it'll help. If you don't do it and turn it in, then it's not going to help. If you don't turn it in and you got a good enough grade, then it does nothing. Okay? Yes, ma'am. They're all up there. If you are missing any of the 5 homework assignments that you already have, they're all up underneath the deer head.